simple equations. Okay, so initially let's start from the beginning. That is, you have simple equation x upon 5 equals to 2. You know how to solve this simple equation. It is having an algebraic expression and there are some numericals as well. Both together it is concluded as an expression that is equals to some quantity. So hence it is an equation as well. So when we solve the equation, x is divided by 5. What is the operation in left hand side? X divided by 5, that is equals to 2. So you have to solve that to get the final solution. So x would be equals to 2 times of the dividend. Okay, dividend means the number, sorry, not dividend, divisor. The divisor will become a multiplicand here. So then x is equals to 10. We know how to solve these kind of simplifications, these kind of simple equations from our grade 8 and 9. But in our grade 10, what we are going to focus is with algebraic quantity fractions. In the LCM and algebraic fractions, we were discussed about how to do the operation in algebraic fractions. That's what you have to implement here as well. For an example, look at here. X over 2 plus x over 5 equals to 14. Okay. You have to solve these simple equation to get the final solution. Before that, do the operation in left hand side separately. Okay, there are two fractions. Since both of these fractions are having x as a denominator, it is simple to make x as a common denominator. Thereafter, you have to add the numerator values 2 plus 5. This is equals to 14. Always keep your equals in an alignment. That will give you some kind of better idea about the simplification. Always keep the equals in an alignment. So 2 plus 7, it is 7 upon x equals to 14. Equals to 14. Our question is solving simple equation. You have to solve this to get the answer for the unknown constant. Here the unknown constant is x. Now by solving this, we need to find the answer for x. So in here we cannot find the x itself directly because that is in denominator form. You have to bring that denominator as a numerator to next side. So what is happening here? 7 divided by x equals to 14. We don't want 7 divided by x. We just want the value for x only, the solution for x only. So I will keep the 7 itself. I'm going to bring the divisor x as a multiplicand. So 14 should be multiplied with x. Now look at it. 14 times x equals to 7. Hereafter I will write the rest of the question here. So 7 equals to 14x. To find the value for x, we don't want 14x either. We only need the value for x. X would be equals to the 7 still remains same. You have to bring the multiplicand 14. In right hand side, 14 is a multiplicand. You have to bring the multiplicand as a dividend. There are many differences between these fractions. Look at them. Here 7 by x is 14. From that we cannot determine x is 7 or 14 likewise. But here both are numerical value. By solving that we can find the solution. So when we simplify this, 1 sevens are 7, 2 sevens are 14. So finally the answer for x would be half. Answer for x would be half. I'll repeat it again from the beginning. There are two algebraic fractions. You have to find the simplest version of the solution for the algebraic fractions in left hand side, that is 7 upon x. Thereafter just simplification. We cannot find the x as a denominator. That's why uh, I brought the x as a multiplicand. So 7 equals to 14 times x. Then the multiplicand 14 will become a dividend. After simplification, x would be equals to half. That's the solution. So in this question we are having 3 upon 4x. 3 upon 4x plus 2 upon x equals to 33. You have to solve this to get the solution for x. Okay, to do that, uh, like our previous question, we cannot add the numerators itself because look at the denominators. The denominators are not same. Here 4x, here x. With different denominator, we cannot do any operation in fraction. So you have to find the LCM for both of them. 4x and x. You have to find the LCM by dividing them by using the prime numbers first. So 2x x, and again we can divide it by 2. That's 2 x x. Again we can divide this by using the constant x 1 1. So the LCM would be 2 times 2 4, 4 times x 4x. 4x is the LCM for these two denominators. But the first fraction is already having 4x itself. So no need to disturb that anymore. We have to disturb our second one because it is having the LCM, sorry, the denominator has x. But you have to bring it, you have to make it as 4x. 2 to 4, 4x, that is the LCM. So to make the denominator as 4x, I am going to multiply this fraction. Multiply this fraction by number 4 to produce equivalent fraction. So it remains same, 3 upon 4x. So the second fraction, it will become 2 4s are 8, 4 x's are 4 times x, it is 4x equals to 33. Now look at the denominator. After making the denominators as identical only, we can do the operation between fractions. Now look at the denominators. Both became 4x. No? You can write the 4x as a common denominator. Do the operation between numerators. Numerators. So 3 added with 8. It is equals to 33. So 3 plus 8, it is 11 upon 4x equals to 33. But we don't want 11 upon 4x. We only want to find the solution for the unknown constant. It is x. So let's find that. So I will bring this 4x as a multiplicand here. So 11 equals to 33 times 4x. And I'll keep the x itself in right hand side. The 11 should be divided by 33 times 4. It is 120, 132. 132. Then finally the x would be. You can keep the answer like this, but it is more appropriate to write the simplest fraction. Both are 11 multiples, both numerator and denominator. When you simplify this by using 11, 1 upon 12. This is the most appropriate answer to our x. What we did, not like our previous example. In this example, we didn't have the denominators as identical values. So we have to make them as same. That's why we used LCM to find the LCM between these two denominators. It is 4x. So thereafter, the first fraction is already 4x itself. Second fraction multiplied with 4 to produce 4x as the denominator. Thereafter, we did the operation between numerators. 3 plus 8, it is 11. Then 4x multiplied with, because look at here, we cannot do the simplification by keeping the x as a denominator. We have to make it as a numerator form. That's why I am going to multiply this one with 33. Try to understand that one clearly. Because we don't want the answer for 1 upon x. We only want the answer for x. That's why I kept it here. So then 33 4s are 132. That's what became a dividend here. Thereafter simplification, 1 upon 12 would be the solution for it. So in the next set of questions, the expression would be like this. Only a fraction like this. When you have 27 upon 5m plus 2, 5m plus 2 equals to 4. Okay, you have to solve this to get your answer. This is the given equation. By solving that, we have to find the solution for the unknown quantity m. So what do we need to do? M is in denominator form. We have to make it as a numerator. Just multiply this with number 4. So 27, that is equals to 4 times of 5m plus 2. 5m plus 2. So thereafter we can expand the bracket. So let's expand 4 times of this one 5m. It would be 20m. 4 times of 2, it is 8. That's equals to 27. Thereafter I will bring the positive 8 first. I will bring the positive 8 as a negative 8 first. 27 minus 8, that is equals to 20m. 27 minus 8, it would be 19, equals to 20m. Then finally the m would be, the answer for m would be the multiplicand 20. That will become a dividend. M is multiplied with 20. When you bring that to next side, that will become a dividend. So 19 upon 20. 19 upon 20. That is the answer for M. Solution for M. I'll repeat it again. The constant which we need to make it as a subject in the given equation in denominator form. So you have to bring it as a numerator. Just bring it, bring this, and thereafter expand the bracket to the opposite simplification. To the simplification, positive 8, that will become a negative 8. So 19 equals to 20m. Then bring the 20 multiplicand as a dividend. So 19 divided by 20 equals to m. Not only this, we have another type of equation like this as well. In that one, what do we need to have is, we will have 2 upon x minus 3 equals to 3 upon x plus 8. Okay. Both, there are two denominators. Okay, this is an equation. In both sides we are having x quantity. So how to solve this? Same thing. This is in denominator form now. It's called as cross multiplication. You are having two fractions. In between you are having only an equation mark. There are two fractions in both sides. In between you are having equation mark. In those cases you can do the cross multiplication. Be familiar with the word cross multiplication. So 2 should be multiplied with x plus 8. While you are bringing this expression, you have to indicate it inside the brackets. That is equals to 3 times of here also x minus 3. Then expand the bracket with 2. 2 times of x 2x plus 16, that is equals to 3x minus 9. Minus 9. We have to bring all the x quantities to one side. All the x quantities to one side and numericals to one side. If both sides are consist of x values, how can we solve that? You have to bring them to one side. So what I am going to do is, I will keep the 3x itself as it is, the positive 2x. In right left hand side you are having positive 2x. This positive 2x will become a negative 2x here. And I'll keep the 16 itself. The negative 9 will become a positive 9. You would be able to do two simplification simultaneously at the same time. So the positive 2x became negative 2x to here, and negative 9 became positive 9. Nothing changed with the positive 16 and positive 3x. And thereafter 3x minus 2x would be x. 16 plus 9, it is 25. This is the solution for our x. I'll repeat this question again. So here the both denominators consist of x quantities. Do the cross multiplication, expand the brackets and bring x quantities one side and numerical one side. Then you will have the solution for your x. So here one more possibility. If you bring the 3x to here, so look at this, after expansion this would be the simplification. 2x plus 16 equals to 3x minus 9. So I will bring the 3x to this side and 16 to next side. So what will become? 2x remains same. This positive 3x, that will become a negative 3x. And negative 9 remains same. You have to keep the direction itself. And the positive 16, that will change to its opposite direction, negative 16. So 2x minus 3x, it is negative 1x equals to negative 25. We don't want the value for negative 1x. No. We need the value for x only. So x is multiplied with negative 1. To remove that, you can bring the multiplicand negative 1 as a dividend. Negative divided by negative is positive. 25 divided by 1 is 25. So to avoid these complications only, I bring this one, because 3x minus 2x somehow will give you a positive quantity for x. So you can simplify that. To avoid this negative complications only, I just wrote this one, the positive 2x to the side where 3x is whole term. You can use this method as well, but you have to be careful with the directions. Let's have a look into the question 1. So first let's multiply them, and you have to multiply these two as well. So 10 times multiplied with x, likewise you have to expand 25 with a minus 3. And then 10 times of 8, 80, and expansion with 25, a 25 multiplied with negative 3, it's negative 75. So look at the numerical value. 75 is not consist of any a quantities. Only that is a numerical value. So you have to bring it as an addition to next side. So 80 plus 75, that should be equal to 25a. Thereafter, a is equals to 80 plus 75, it is 155 divided by 25. We can simplify them by using number 5. So 31 upon 5. A is equals to 31 upon 5. Since 31 upon 5 is an improper fraction, you have to denote it by using a mixed fraction. 6 into 1/5. This is the final answer for A. And for the question number 2, let's do the cross multiplication. 2 times of x plus 8, that is equals to 3 times of x minus 3. Let's expand the brackets. So 2x plus 16 equals to 3x minus 9. And I'll bring 2x here. This is the same question which I explained earlier as well. 2x will become here and 16 remains same. I'll shift the negative 9 as positive 9. So 25 equals to x. X equals to 25. That is the overall solution. The denominators are same. Even though these are expressions, the denominators are same. So I can write the same denominator. Do the operation between numerators. 1 plus 3, it is 4, equals to 2 upon 3. Hereafter you know how to do this question. We can cross multiply the expressions. So 4 times 3, it is 12. 2 times of a plus 1, it would be 2a plus 2, that is equals to 12. Bring the 2 as a subtraction. So 10 equals to 2a. So a would be 10 divided by 2, it is 5. A is 5 here. The denominator is same. Okay, look at this. This is the common denominator because both denominators are same, so you can keep it as it is. Next question, 5 upon x minus 2 plus 3 upon x minus 2 equals to 2. So what would be the answer for x? Look at the question. Initially, look at the denominators. The denominators are not same. No? This is 2 times p plus 1. This is just p plus 1 only. So what you need to do? You have to multiply only this fraction, the second fraction, by 2 to make 2 into p plus 1 as the common denominator, because it is already having 2 times p plus 1. The second fraction only consists of p plus 1 quantity. You need to multiply that 1 by 2, that fraction, by 2 to produce 2 into p plus 1 as a common denominator. Thereafter, you can do rest of the operation. So hereafter, we just made the denominator same. Okay, I explained why we need to how we need to make the denominators as same? By multiplying the second fraction by number 2. So 5 plus 2, it is equal to 7 upon 8. Okay. Then 5 plus 2, it is 7 upon 2 times of p plus 1. It is equals to 7 upon 8. I will do the cross multiplication here. So it will become like this. It should be multiplied with 7, 8 multiplied with this. So 8 times of 7, it is 56. And already there is a 7, it is multiplied with another 2 times p plus 1. So you have to multiply both 2 and 7 because already there is a 7. Here also you are having a common factor 2. No? Both should be multiplied. 56 equals to, it is 14 times of p plus 1. Not only 7, not only 2. 14 times of p plus 1. So 56 equals to 14p plus 14. Then I will bring the positive 14 as a negative 14. 56 minus 14 equals to 14p. 56 minus 14, it is 42 equals to 14. So p should be 42 divided by 14. So finally the answer for p, it is 3. It should be 3. You have to be clear while you are multiplying this. Okay, most of you are doing the mistakes while multiplying this here. Okay, you can directly multiply. You might do with 2 or 7 only, but here there is a 14. You have to expand with 14 and do the rest of the simplification.
First, the simplification, the denominators are not same, so I will multiply the second fraction. It is already having p plus 1 quantity only, but the LCM would be 2 times of p plus 1, so it should be multiplied with number 2. So thereafter the common denominator became 2 into p plus 1.
Mostly I can see this mistake that here look at here 2 times of p plus 1. Mistakenly students will write like this 2 2p plus 1. This is incorrect. Okay, this is incorrect. You have to keep it inside the bracket 2 into p plus 1 and 15 minus 3 times of 2, it would be 6. That is equals to 2. That is 2. So 15 minus 6, it is 9 upon 2 into p plus 1. It's 2 equals to 2. So what you need to do? You have to do the cross multiplication. This expression would multiply with 2. Look at this. Already it is having a 2. Another 2 is also here. Both together 9 is equals to 2 times 2. It will become 4. 4 times of p plus 1, that is equals to 9. Then let's expand the bracket. So 4p plus 4 equals to 9. Thereafter
9 minus 4 equals to 4p. 9 minus 4, it is 5 upon 4. It should be the answer for p. I'll repeat it from the beginning again. Look at it. So what I did first was, the denominators are not same, I made them as same by multiplying the second fraction with number 2. So thereafter the common denominator became 2 times of p plus 1. Then 15 minus 3 2s are 6, and 9 upon 2 times
into p plus 1 equals to 2. I just made it as a multiplication. Thereafter 2 times 2, it is 4 times of p plus 1 equals to 9. Thereafter just I shifted the positive 4 as a negative 4 here. Okay, dislocated. Thereafter it will become 5. 5 divided by 4, that would be the solution for p. So in the question what happened was, you cannot do the question itself. Just bring this one here. Okay, or else you can bring this quantity to this side. Look at them. Those quantities look identical. No, I'll keep 3 upon 4 itself. 4 upon a minus 1. I will bring this one as a minus 1 upon a minus 1. This is the way you have to think, interpret the data and apply this knowledge. A minus 1 would be the LCM and 4 minus 1, it is 3. It is equal to 3 upon 4. Thereafter let's do the cross multiplication. 3 times of a minus 1, it is 3a minus 3. 4 times of 3, it is 12. So 3a equals to 12 plus 3, it should be 15. And a is 15 divided by 3. Finally, the answer for a would be 5. That's all. This is not like the traditional question. There is a you have to think properly to apply your knowledge to complete the question. If not, you have to bother with this number 4 and something else. So to avoid that, you can bring the identical quantities to one side, solve them, then cross multiply, simplify to get the a as 5.